Hello everyone. Today we are going to see the text generation. Okay, so text generation, so making AI write like a human. So which you might have already done using ChatGPT, correcting your emails or generating the email responses or writing something in the ChatGPT, right? So, but we are going to use some libraries today other than the ChatGPT and look into that. Okay, so text generation is when AI writes human-like text based on a given starting phrase. For example, if I give once upon a time, it should be able to write, yeah, once upon a time there lived a king, and king has seven wives, something like that. So basically once we provide the prompt or a given starting phrase, it's going to do that. So it is helpful to generate the human like text in the chatbots, so some sort of content creation on the websites, and summarization as well, text summarization. Okay, so in the chatbots, AI would be able to respond to the people's messages. Okay, in the content creation, it's going to writing articles, stories, and source code even automatically. If you provide a map reduce program in a big data, it should be able to write the piece of code for you. Okay, so similarly text summarization. So how this text generation would work, as I said, you need to provide a starting sentence or a starting prompt or a starting phrase first, and AI would predict the next words. Okay, and it would generate the full response. Okay, so for example, the input is the future of AI is bright, and new developments in robotics, automation, and in deep learning would happen. Okay, so how we are going to write the source code here is we are using Hugging Face transformers, TensorFlow, and PyTorch. So it helps us to use some of the libraries, and then we will be able to generate the text here. Okay, so we are going to use several tokenizers and deep learning models as well. Okay, let me go to the text generation, my GitHub repository thing. Yeah, so make sure you read the goal, introduction, all that stuff. So the input is like once upon a time. So once upon a time in a small village, nestled between rolling hills and dense forest, it generated something, okay, using once upon a time. So a quick overview here is a prompt is provided to the LLM, and that LLM is going to encode the prompt and convert into tokens. So basically this is similar to our transformer model, which has been discussed in module 2 when I was in the class. Okay, so which attends the required tokens and generate the text. So we are going to use the transformers and PyTorch both, install them, and then import those packages, get the transformer name. I think we are going to use GPT-2 as a transformer, and load the corresponding tokenizers and deep learning models, provide a prompt and convert the prompt into understandable tokens using encoder, and we need to do an attention. Okay, so this attention is very important. Remember, we also discussed this in the module 2. Okay, so you could always go back and check your notes and generate the output. So yeah, we have pip install transformers, it installed, and pip install torch, it installed. If you look at when you install PyTorch, you have like NVIDIA libraries has been installed. And you need to write the source code. So first thing is just import the some deep learning models that you are going to use from transformers. You need to import GPT-2 large model here, and then GPT-2 tokenizer as well, and then import the torch. So model name, so I'm saving this in a local variable and use that local variable name here. So GPT-2 dot from pre-trained model name, which is GPT-2. So save that in a tokenizer. Once you run this, you are going to get the tokenizer library stuff. Load the corresponding deep learning model. So we are loading the deep learning model here, which is GPT-2 LM head model. So, and store that in a model variable, local variable here, and the model name is already coming from GPT-2 here. Okay, so it loaded the necessary models, and you are providing a prompt. A prompt is a world where humans are replaced by robots. um, convert the prompt to machine understandable format such as tokens using the encoder. So we remember we used positional encoding and all that stuff, which uses lots of math and the data. So with a regular CPU, we may not be able to use all those permutations and combinations. So using that encoder, we are using the tokenizer.encode. We are passing the prompt. We are applying our PyTorch, PyTorch, and make sure add some special tokens also. So when you add some special tokens, which gives you the like a text that you are going to indicate that your prompt would make some sense. So which would be able to identify different meanings of a given prompt there. Okay. And then definitely an attention. So this attention would definitely identify what is necessary and what is unnecessary. So that's what is attention. Let's say if I'm providing my attention to only one student, maybe Anil or Akash, so that means my attention is towards them, not to someone else. So that means I'm filtering all the unnecessary subjects. I'm focusing only on the particular persons. So attention is all about the AI generation actually. Okay, I think we discussed this also in the module 2. Okay, so attention mask is here dot torch, so you're doing its IDs and you're passing this. Okay, so this attention mask would filter unnecessary tokens here. So how to generate the input? You need to provide the IDs, the mask, maximum length of essay that you want to generate, maximum number of return sequences, all this stuff I recommend you to read. But basically these are the comments for your code actually. Okay, so you are using the model to generate input IDs. Attention mask is given. Maximum length of generated sequence is 100, and number of sequences to generate number of return sequences is 1, and not repeat is to avoid any kind of repetition. We are trying to do only 2, maximum of 2. Top K and top P. Okay, so these are the two important features in your chat GPT as well, to filter out some of the tokens of the probabilities and to filter out the cumulative probability exceeding this threshold. Okay, so that means you're going to generate the top tokens of 50 in the probability, and top P value is the final cumulative probability exceeding this threshold. That means I'm focusing on the accuracy, the probability of 0.95 and more. Okay, but below that I'm not focusing here. Temperature is 0.7. If you use the lowest temperature, you get the accurate results. If you use the highest temperature, that means 0 to 2, I believe. If you use highest temperature, you get the more randomness, which is not so good. Okay, so as low as the temperature, you get the better results. Okay, so we are going to use to generate the text by using the decoder. So remember the transformer architecture, positional encoding, and then encoding, positional encoding. You would be doing attention, multi-head attention, and pass that to your decoder, and decoder would be able to reconstruct it, right? So same way here it's happening. You're going to reconstruct it based on that probability and all that stuff. So this is the result that we get. Whether good or bad, that's a different story, but this is what we are getting. A world where humans are replaced by robots. Okay, so I can show you my Google Colab, which has been executed here. Yeah, world has been, I'm using the same. So everything has been executed. This one. Okay, so I recommend once you're done with this source code, sorry, not source code, text generation in the using my Google Colab, I would recommend to go and see the different properties or attributes of the chat GPT, like top P or temperature that controls the randomness, all that stuff. That way you could be able to notice that. So In the module 4, we'll see more of those for generating the chatbot stuff. Okay, so which I'm not going to discuss here. So look at this in the Hugging Face module, Hugging Face library, where you could be able to see the text classification and text generation, right? So we are going to see the text generation. So this is one of the Mistral is good thing here, which is 24 billion parameters. Using, and if you notice, there are lots of with the DeepSeek AI. This is from China, which is the more powerful, I believe, more efficient than the ChatGPT, I believe, which I haven't tried yet. At least by the time of recording this video, I haven't tried. See, look at this. So it has these many records of downloads in the past. Okay, so it provides all these things. I would recommend you to read those things. That way, you could be able to identify what is good, what is bad, and how you could be able to compare. If you want to generate your own model later on, that could be a good project in this course. Okay, so let's see. It's all Mistral, DeepSeek, Distill. So wow, this is good number 2. Okay, so let's focus on this as well. Okay, so that's all I have for you today. Thank you.